All right, so in this video, we're going to talk briefly about differential equations, and many of you will actually go on to take a full course of differential equations once you get past the calc sequence, but this is just a mild introduction, and you'll see them throughout the calc sequence from time and time again, but nothing to the degree that you would see them in the actual course. So a differential equation is very basic. It's an equation that has derivatives in it, and our job in solving them is to find the solution. Now, the solution will be one of two things, either the general solution or the particular solution. So general solution or a particular solution. Let's take a look here at an example real quick. Now, this is one, again, pretty small, one that we've worked before, but I picked it because not only have we worked it before, but I can visually give you a little more information than if it was a messy function. So from this guy here, if we want to solve this, we would, of course, again, move the dx to the other side. And then to get rid of the derivatives, we would take the antiderivative. And we would end up with y equals our x squared. And then don't forget the plus c. So this guy right here, and I'm writing it y of x for what's coming in just a minute. This guy right here, this is the general solution for the differential equation. Now, it's a general solution because it has the plus c in it. If I were to graph this, you would have infinitely many curves because you would have infinitely many c values. Remember, c is a constant, and so by the way this is set up, x squared plus a constant would be a parabola shifted up and down c units. So if c is 0, we get this curve right here. If c is 1, we get this curve here. If c is -1, we'll get this. And so depending on what c is, you're just getting a bunch of these parabolas that open up. Okay? So that would be our general solution if it has the plus c in it. Now, to figure out the particular solution or a particular solution, we would be given something like this, where this is called an initial condition. And many times you'll hear these referred to as initial value problems, IVP. So if you're given something like this along with the differential equation, you're going to be able to solve for c, therefore find a particular solution of it. So down here earlier I wrote y of x because I knew what was coming. So now if we evaluate using that point, we would get y of 2 equals 2 squared plus c, and that would equal -1. All right, I put my 2 in here for my x, and then y of 2 equals -1. So if I solve this now for c, that's a 4. If I subtract it over, my c value here would equal -5. So now y of x equaling x squared minus 5, that's going to be my particular solution. And instead of having infinitely many parabolas that open up, we just happen to have one parabola, and it's the one that shifted down 5 units right here. This would have been your -5. And it's this one because it's going to go through the point here to -1. So that point to -1 that we started with up here, that's where that point is. We picked the correct parabola that went through the point that we cared about. So again, a difference between a general solution and a particular solution. And graphically, that's important to understand as well. And so the last thing I want to talk about in this section is antiderivatives of motion. So what I have up on the screen is something that we've actually done in the past, where if s equals f of t is a position function, if we take the derivative of position, we end up with velocity, right? The change of position with respect to time is velocity. And if we take the derivative of velocity, we end up with acceleration. The change of velocity with respect to time is acceleration. So now that we have this antiderivative idea, it's going to allow us to work backwards. For example, if I now have acceleration, and I take the antiderivative of it, that's going to give me now velocity. Similarly, if I have velocity and I take the antiderivative of it, that's going to now give me position. So now we're able to work not only forwards but backwards depending on the given information for the problem. The book's got an example worked out of, it's example 5. So example 5 on page 234, at the very, very bottom of page 234, where it walks you through some of this. Again, if it's been a while since you've seen it. As well, I've got a problem on the homework, number 107 out of the text, that you guys will work through and hopefully get a better feel for not only moving forward but now backwards using these antiderivatives.